Hello everyone, welcome to another session of Vista Export Services. In this session, I'll be introducing you to a new script called CameraMatch AutoSetup. This amazing new script uses advanced computer vision to automatically detect and draw vanishing lines in photographs and automatically create perfectly aligned 3D cameras in your scene. Users can also export the final 3D match cameras as an FBX file to other applications with a click of a button. There are also working versions of this unique script for 3D applications such as Blender, Sketchup, Maya, Autocad and many others. At the time of this video, users can currently download the free PDF installation manual on a link below for 3ds Max and Blender. The remaining installation manuals for other applications will be available by next week. Do contact me for any specific application versions you might be interested in. So without further ado, let's start by clicking on the Scripting tab and choosing to run script. Choose the script name CameraMatch AutoSetup V6 and open it. Here's the CameraMatch AutoSetup dialog. In this browse for image toggle here is where users load the photo they wish to camera match automatically. Let's click on it to load the image first. This is a list of the automatic actions the script will take once the Auto Detect VP and Apply to Camera button is clicked. So the script will automate the vanishing point alignment first, detect vanishing points automatically, compute the field of view, tilt, pan and camera roll, and automatically draw the horizon for camera alignment. Let's click the Auto Detect VP and Apply Camera button now. It should take a few seconds to calculate and execute the final result depending on the complexity of the photo previously loaded. Once the calculations are completed, simply click Yes to the Apply VP Camera Parameters if you're happy. Click OK to the Done dialog summary. As you can see in the camera viewport, the 3D camera was automatically created accurately. Also, the final image with accurate vanishing lines and the horizon line are drawn and automatically inserted into the camera viewport background. The script also created automatically this reference box in the scene to be later used as an alignment reference for the final camera positioning parameters. Let's move the box away from the camera to align it with some of the background photo elements. Next, let's select the camera and open its modify panel here. Let's double click the camera target to ensure it's enabled. Let's click here and choose the select camera target option from the list. This background image horizon line was automatically calculated after these vanishing lines were created. While the camera target is selected in the viewport and the move tool is also enabled, begin moving it vertically to bring down the camera horizon line to align with the background image horizon line. This grey line is the scene's grid, which is often on the same level as the camera horizon line. Let's select the box in the scene and begin moving it downwards to align with the base of the background image there. As you can see, we can begin moving the box in the camera viewport to double check everything aligns accurately. Let's increase the box height to ensure everything aligns as expected. Also, let's edit the box to make some quick changes to it. Everything seems to be lining up accurately as expected. As you're able to see, the entire process of running the script to automatically create everything you see and vertically move the camera target to align with the background image horizon line took less than 1 minute. Users can also select and export the match camera as an FBX file format to be later merged into other 3D applications. To do so, first select the camera in the scene again, click this button to export camera to FBX, click to save. As you can see, the export is complete. This dialog picks all the camera parameters exported as an FBX file. Let's open a new 3ds Max file. After going to File, let's choose to import and bring in previously saved FBX file. And that's it really. There are other manual fallback features such as the perspective match tool and others seen here for when there are no objects with visible perspective lines in a photo for the script to detect. These additional tools are useful for such rare instances. Having said that, this script will work perfectly on 90% of images that contain objects with clear perspective line. The next step is to run the script on other types of images that could potentially benefit from its powerful functionalities. Let's start by resetting the scene and closing the script dialog first, and go through the same process with a variety of different images as an example. This is one of the extreme examples where there was a bit of a camera distortion and the horizon line was calculated a bit lower than it should have been. To quickly correct this, we are simply going to move the camera target vertically to where we think the true horizon should have been. Instead of using the script's horizon line here, we are going to move the camera target to about here, where the true horizon should have been. A really good way to ensure the horizon is correct is to simply place a reference box in the scene where we can easily compare the perspective lines against the background photo. As mentioned earlier, we simply need to move the camera target vertically to where the horizon should have been. And that's it. No camera rotation or new camera position with different parameters are required. As you can see, this is the best way to ensure the horizon line is where we should have been. I really hope you've enjoyed the script and tutorial, and I hope to see you on my next one.